So we have seen how to catch unhandled exception using inbuilt and custom middleware in our previous video. Let's work more on this custom middleware and add more functionality at this level in this video. So at present we are returning this error message in just plain text format. I think it would be better if we return this error in JSON format with more details, so that our API client can use that information to display proper error message in their application. So at the root level, let's add a new folder and name it errors. Add a new class here. Name it API error. We are going to use this class to return an unhandled error to our client. And that error should have an error code of type integer. It should contain error message. And it should contain error details. We are going to return an error trace in this field. Add a constructor of this class so that we can initialize all these fields at the time of creating the instance of this class. In VS Code, we can create a constructor by pressing the control dot on a class level, and we can use this generate constructor with this 3 dot. And it automatically creates constructor with public field initialization code. Let's make this field optional by assigning null value as default. I'm making this optional because this contains error trace, and I would like this to be populated only in case we are running our application in development mode. Now we can use this class in our exception middleware. Let's inject the iHost environment as well here, so that we can display our different levels of information on the base of what environment we are in, like development, stage, or production. Initialize this field. So now at this catch block, we will use the object of API error. Let's name it response, and on the basis of a different environment, we will return different level of information in error response. So if the environment is development, a response should be a new API error, and it should return error code. Let's add a variable of type HTTP status code and assign internal server error as the default value, and use this variable here in constructor. We need to typecast it to integer. We will return exception message and also exception stack trace as it is development environment. And if it is not a development environment, we do not want to return this stack trace to the client. Let's replace this hard-coded code with our status code variable. And as content type of our response will be JSON, set it to application/JSON. And here we will return the response object, convert it to string, save it and test the API. So if I try to get cities, we are getting this namespace of API error, and I was expecting this only. The reason behind this is we have to serialize an object to pass it from one domain to another. Serialization is basically the process of converting an object into a stream of bytes to store the object or transmit it to the memory, a database, or a file. Let's override this toString method in our class so that we can serialize our object. There are multiple types of serialization we can apply on our object, like binary, JSON, or XML. As we want it to JSON serialize, let's use JSON serializer. Bring in system.text.json and serialize this object. Save it and run the application. And send a request again on getCities endpoint. So this time we get error response in JSON object as expected. And because we are running our application in production environment, we get null in this error detail field. Let's change it to development and rerun the application. This time we should get error stack trace as well. And yep, we are getting error detail in development mode. So at present we are returning 500 error codes for all types of exception type. Next we'll see how to modify this error code for different types of exceptions. Let's add two variables, one for message and another one to get exception type. And to get the type of exception, use exception dot get type method. Now we can modify the status code and error message on the base of different types of unhandled exceptions. For example, if exception type is the type of unauthorized access exception, that means someone trying to access any endpoints who is not authorized. In this case, we want our status code to return the error of type forbidden and return error message, you are not authorized. We can use more else if statement if needed to handle different types of status code and messages here as per our need. And in the else part, let's return internal server error and return a message saying some unknown error occurred. Here as a response, let's keep returning original error message if we are in development environment and change it to return our custom error message in the production environment. Let's run the application. We are in development mode. If we will send a request on this getSetis method, see, this error code has changed to 403 and this error code belongs to a forbidden error. As we are in development environment, this error message is not modified. Let's run the application in production mode to see if this error message display our custom error message. Yep, this is now showing our custom error message in production mode. And at terminal level, we get this original error message. And if we send a request on this update city method, we should get an internal server error. Perfect, we get this 500 internal server error and our custom error message. So you have seen ASP.NET Core middleware pattern gives us a clear and elegant way to interrupt execution and handle error conditions globally. We can also send a mail to the concerned person if any unknown error occurred in our application. So those can be handled in application as soon as possible. There are a lot of possibilities and you now have an idea what you can do at this level. I would like you to explore more real world scenario to handle in this middleware and try to implement the same. Also, one more thing you can take as an exercise is that I have written all of this code in catch block. You can take initiative to refactor this code by creating different methods for different types of work. And the last thing I would like to modify is in startup.cs, I would like to use this code in extension method and call that extension method instead of directly calling this use middleware method here. So add one more method in our extension method. Let's rename it to configure built-in exception handler and add the use middleware method here that we are currently doing in the startup.cs file. Now we can remove this line and let's uncomment this line to call our extension method. So in case you will have to use built-in middleware, you can just call our another extension method here like this. So we have completed exception handling. Next in our list is security. At present, any anonymous user is able to call the different methods on our API. if they know the endpoints. In the next few videos, we will make our API secure. We will use a JWT token based authentication to authenticate all the incoming requests and return an error if the user is not authenticated. So see you in the next video. Stay tuned. Bye bye.